defined these sine and cosine in terms of x, y, and r. And of course, when we talked about tangent, we knew that the tangent of my angle is my sine of my angle over the cosine of my angle. This is what we got from yesterday. And our cotangent, of course, is the reciprocal of that. So it is the cosine of my angle divided by the sine of my angle. So we had all that from yesterday. What we're going to look at today is finding exact values for the angles. And if I'm asked to find the exact values and I'm given a point, then the first thing I'm going to do is I'm going to find my r value, because everything's in terms of x, y, and r. So if I take a look at, which one do you all want me to do? A? All right, so I'm going to do A over here. So I know that if I have the ordered pair, -2, -2, then right out of the gate I have my x value, and I also have my y value. So if I have my x value and my y value, I already know my tangent, and I already know my cotangent. So I know that my tangent is going to be equal to my y value over my x value, which happens to be 1. My cotangent is the reciprocal of this, so in this particular case, my cotangent and tangent are the same thing. So they are the same thing on this one. I do need to find all the rest of them, and to find all the rest of them, I do need to find my r value. The way that we define r is the square root of x squared plus y squared. So I'm going to find r, and it's going to be -2 squared plus -2 squared, all underneath the square root. So 4 plus 4 under the square root of 8, or in other words, 2 root 2, simplified. Is there any questions? All right. So now I'm going to go ahead and find all the rest of them. So the sine of my angle is going to be my y value, which is -2, over my r value, which is 2 root 2. You don't have to rationalize, but you do need to simplify. And in this case, my -2 and my 2 cancel, and I get -1 over the square root of 2. If you would like to rationalize, you may. I'm not going to ever ask you to do so in this class. And if you decide to rationalize, it is the square root of 2 over 2, and it's the negative of it. So if I have my sine, I now have my cosecant, CS, C of alpha, which is the reciprocal of this. So my CSC is now going to be negative square root of 2 over 1, or just negative square root of 2. I'm going to do my cosine, which is going to be my -2 over 2 root 2, which is -1 over the square root of 2, or if I want to rationalize, -2 over 2, square root of 2 over 2. Once I have my cosine, of course, I have my secant, which is negative square root of 2. Is there any question?
Yeah, how'd you get the secant again?
The secant is the reciprocal of this. So it is the negative square root of 2 over 1, or in other words, just the negative square root of 2.
It's the reciprocal of the cosecant.
Cosine. Secant is a reciprocal of cosine. Cosecant is a reciprocal of sine. And you'll notice when I write these, I write them together because they belong together. Sine and cosecant, cosine and secant.
Wait, the thing that you have written right under sine, isn't that cosecant?
Yes, and it belongs with the reciprocal of sine. Cosecant and sine are reciprocals.
So secant down at the bottom you have
Is the reciprocal of cosine. That's why I have it underneath cosine. Yes.
So you use the N1 and the 2B on top?
Yes. So the question was, if I decided I wanted to rationalize the sine and cosine, which I absolutely could, then these answers here would have been 2 over the square root of negative 2 over the square root of 2, and it would be a negative in there. But I don't have to. You don't have to ever rationalize. All right? Any other questions?
So does that mean that that's 45 degrees?
Yes, but we're getting there. All right. Please do B, C, and D. And I want to find all 6 of them going through that point. The first thing you have to do is find R if you want to find the sine and cosine. If you want to just jump right in and find tangent and cotangent, you can find those right out of the gate without any work. But sine, cosine, and the reciprocals, you do need to find R. If we take a look at B and C, we're just going to talk about these very briefly. These are special triangles. They're special triangles because when you find the radius, it is a nice integer number. So when you do B and you do the radius, you find that this is 13. And the next one is the very special 3, 4, 5 triangle. Here my R happens to be 5, so it's a 3, 4, 5 triangle. So if you are ever like, man, I need to make sure this baby is a right triangle, you measure out 3 feet, you measure out 4 feet from the corner, and hopefully from point to point it is 5 feet. If it's not, you don't have a square house, possibly. Hopefully not. This one we're going to find the radius, and when I do the radius, it's going to be negative 6 squared plus 4 squared. When you do 6 squared, you get 36 plus 4, or 16. So what's 36 plus 16? 52. Do I have any perfect squares embedded in there? 4 doesn't go in there?
Yeah.
Well, yeah.
2.
How many times does 4 go in there?
2 times. 4 times.
How many times? 13. So this is 2 root 13.
Yeah.
You don't have to rationalize, but you do need to simplify your rationals here. So if 52, it has a perfect square embedded in there, and they're like, did you tell them that that's what they had to do? Is that what you I just want to let you know that my last quarter in my pre-calc 1 class, it was the ladies that always had the highest grades. Just saying. It's true though. The ladies had the highest grades, so men, let's step it up. Gotta step it up. On this one, we are finding the radius, and then once we find the radius, we have all that we need to find tangent, cotangent, secant, cosecant, sine, and cosine. I would have started out with finding the tangent and the cotangent right away because I didn't have to do any work. The tangent is going to be negative 4 over negative 6, because it is your y value over your x value. You do need to reduce this, and it ends up being negative 2 over 3. My cotangent right out of the gate then is negative 3 over 2. So I have those without any real work. The only work I had to do was find my r value. Once I find my r value, I can find my sine of my angle. And the sine of my angle is going to be 4 over 2 root 13. Again, you don't have to rationalize the 13, but you do need to reduce. So you get 2 over the square root of 13. Once you find the sine, you automatically have the cosecant, which is square root of 13 over 2. And then I just have to find the cosine. So when we find the cosine of my angle, it is going to be negative 6 over 2 root 13. And that reduces to negative 3 over square root of 13. And that means I have my secant of my angle, which is the square root of 13 over negative 3. One of these is always on the test. So is there any questions? Okay, and it's like a 6-point question. So it's a nice 6-point question. Yes?
Is the formulas for finding each of those on the formula sheet, or is that something to memorize?
Have you looked at the formula sheet? Okay. Let me, the very end, I'll pull up the formula sheet, and I'll show you where to find it again, and also please consider downloading and printing it so you know where everything is. All right, now on these, they're telling us that we're in a certain quadrant, and I want to find the cosine that's related to that, or maybe the sine, or maybe the cosecant. So up until now, we didn't have to really talk about quadrants because our values all shook out, whether they were positive or negative, all shook out based on the ordered pairs that we had, and we didn't have to really talk about quadrants. But on A, in this first example, where is A? What quadrant is A in?
3.
So this is in quadrant 3. Where is B?
1.
Where is C? Where is D? Don't sound so enthused, you all. You're all just so enthused. So the reason I'm bringing that up is because when I'm in quadrant 3, do I expect cosine to be a positive answer or a negative answer? I expect this to be negative. So because this is in quadrant 3, I expect this to be a negative answer. And I'm just doing that to remind myself when I do my x, y, r stuff that I need to have a negative for my x. Remember that r is equal to the square root of x squared plus y squared. That means r squared must be x squared plus y squared. So if I need to find x, it's going to be the square root plus and minus of r squared minus y squared. If I need to find y is going to be plus and minus r squared minus x squared. So go ahead and find A, B, and C on these, please. And there should be a slight correction here. On this last one, it should be a negative square root of 2 over 5 because I'm in quadrant 4. There should be a negative there. It's not going to change the answer for cosine, but it should be a negative square root of 2 over 5. Going back to A, however, I'm going to find my r. When we found r, it is going to be the square root of 25 minus the 16, which is square root of 9, which is 3. I'm in quadrant number 3. Do I expect cosine to be positive or negative? Negative. So my cosine is my negative 3 over 5. Is there any questions on that one? All right. Looking at the next one, my r here is going to be the square root of 121 minus 4, which is a square root of 117. I'm in quadrant 2. Do I expect sine to be positive or negative? I expect it to be positive. So I have my, that's my y, sorry, that is my y here, and up here this should have been my x. So used to doing r. So up there that was my x, and then the other one is my y. So I'm so used to doing r, I'm like, oh, let's just do r. It is a square root of 17, which is your y value, over your radius, which is 11. So any questions on those first two? All right, here I am chasing the x value. So x is equal to the square root, and that's going to be 25 minus 2, which is going to be the square root of 23. I'm in quadrant number 4. Is my cosine going to be positive or negative? Positive. So this is going to be equal to the square root of 23 over 5.
How do you know you're in quadrant 4 again?
The question was, how do I know I'm in quadrant 4? Is because I know that my angle is bigger than 3 pi over 2, which is 270, or straight down. But it's going to be less than 2 pi, which is to the right. So I know I'm in quadrant number 4. Okay, we're going to spend some quality time, most of this, in the unit circle. The reason we like the unit circle is because when I do the cosine of my angle, it is the x value, and when I do the sine of my angle, it is the y value. The reason that is true is because all of these formulas up here were all based on my radius. If my radius happens to be 1, so if I make this 1, and I make this 1, and I make this 1, and I make this 1, then what I end up with on the unit circle is my cosine of my angle is going to equal my x. The sine of my angle is going to equal my y because I'm dividing by 1. So if I'm on the unit circle, then I know that my x is my cosine value and my y is my sine value of that angle. That then allows us to start talking about some of the angles, specifically what they are in terms of the sine, cosine, tangent, cosecant, and such. If I am 0 degrees, which means I am right here and I'm on the unit circle, this is the ordered pair 1, 0. So since that's the ordered pair on the unit circle, then at 0 degrees, sine is 0 because my y is 0. That means its cosecant is undefined because I'm doing 1 over 0, which is undefined. My cosine is 1 because that's my y value, or my x value, and my secant, the reciprocal of 1, is 1 all day long. My tangent is my y, right here, divided by my x, right here, and so I get 0. And then for the cotangent, because it is 1 divided by 0, it is undefined. So as we go around on the quadrantals, we are just chasing these points, 0, 1, when I'm 90 degrees or pi over 2. I have negative 1, 0 when I'm at 180 degrees or a pi. And then, of course, 0, negative 1, which is 270 or 3 pi over 2. And then back to 360 or 2 pi. All right? And that all comes from the fact that we are now looking at ordered pairs. Do you think that's going to change if I told you that my radius is 16 and my theta is pi over 2, and I want to find the sine of theta? Do you think any of those are going to change? Do you think any of those are going to change if I scale up my radius?
No, because you still have zeros for the signs.
Pi over sine is negative.
Still gonna be positive.
You all put in your calculators, I don't care if you're in degrees or radians, put in the sine of, if you're doing in radians, the sine of pi over 2. And if you're in degrees, do the sine of 90. So if you're in radians, and it should say RAD across the top of your calculator, do pi over 2. If you're in degrees, it should say DEG on the top of your calculator, 290. What do you all get? So does it matter what my radius is when I'm at 90, 180, 270, 2 pi? No, it does not matter. We talked about this yesterday, about what's positive, and remember it is, all of them are positive. Sine and its reciprocal are positive. Tangent and its reciprocal, and cosine and its reciprocal, and it's all students take chemistry, not what I learned in high school. I'm going to give you the reason behind the 45 being what it is. So if I take a look at my 45-degree angle, my x and my y are exactly the same. It is an isosceles triangle. If I build this a triangle right here, if I build this triangle as a 45-degree angle, this part is 90. That means this part also has to be 45. So my x and my y are the same thing. So if my x and the y are the same thing, let's just put in two numbers. What do you want to put in? Two numbers. What is it? 12. So let's look at the ordered pair 12, 12. Let's go through the whole sine, cosine stuff. So I need to find my radius. My radius is going to be 12 squared plus 12 squared, which is going to be 12 root 2. My sine of my angle is going to be 12 over 12 root 2. Which is root 2 over 2. Let's do the cosine of that. Do you think it's going to matter if I would have chose 15 and 15? No. So the 45s for sine and cosine, regardless of the radius, is going to be square root of 2 for sine and also the square root of 2 for cosine. The only thing that's going to change is where that 45 degree is in terms of a reference angle. So if I put here and I did a reference angle is 45 degrees, what is my sine of this angle here? If that's my theta. It is going to be negative root 2 over 2 because sine is negative in that quadrant. My cosine, negative root 2 over 2. So my 45s, whether it is a reference angle or it's a 45 in my first quadrant, is always going to be root 2 over 2. Just have to make sure it's positive or negative based on where you are in terms of the quadrant. Now, if we take a look at the 30 and 60, if we first build a 30-degree triangle here, in other words, there's 60 there, what I know for the 60 is that this and this is the same radius. And in particular, this is 30, or this is 60, and each one of those 60. So what kind of triangle is it if every angle is 60? It is equilateral. So if this is R and that's R, that must also be R. So we all have the same values. So if we come over here and we take a look at this particular triangle, here is R, here is 30, here is 60. We know this must be 1/2 R, right? Because it's half of the triangle that I started out with. If I want to find what this missing side is right here, then I'm going to use Pythagoras' theorem. Now remember, we are looking at R being 1, so let's do this with a radius of 1, but it wouldn't have mattered. We'll still get the same thing. If I want to find that missing piece would be either X or Y. I'm going to call it X. And so my X is going to be the square root of 1 squared minus 1/2 squared. So I have the square root of 1 minus 1/4, which is the square root of 3 over 4, which is the square root of 3 over 2. So the 30s and the 60s, I have the square root of 3 over 2 for my X. That's X. My Y is going to be 1/2. Does that make sense? So we end up with, in the first quadrant, these angles and these answers for the angles. If we're doing a 30 degrees sine, or the cosine of 30 degrees, square root of 3 over 2. The sine of 30 degrees is 1/2. If I take that triangle I just built and rotate it so that my 30 is here and my 60 is here, notice how these two switch position. I still have the 1/2 and I still have the square root of 3 over 2, but the x's and the y's switch position because I rotated the triangle to make it work that way. And then of course, here is my sine and cosine for the 45s. How are we doing so far? Did I lose anyone? Is there any questions? Am I going too slow? Too fast? Too fast? Okay. So, find the exact values without using a calculator. The first thing you want to do is figure out where you are. You need to figure out what quadrant you are in. So I'm looking at the cosine of 120 degrees. What quadrant am I in? I'm in quadrant number 2. So if I'm in quadrant number 2, and that's 120, the first thing I'm going to do is figure out what my reference angle is. So I need to figure out how much further I need to rotate to get down to pi, or 180. How far more do I need to rotate? 60. So I can evaluate this as the cosine of 60 degrees. Now I just got to remember I'm in quadrant number 2. Should cosine be positive or negative? So I'm going to put a negative outside of that because my answer needs to be negative. So I need to do the cosine of 60 degrees. So I'm going to go back up here, and my reference angle was 60 degrees, so I'm going to be using this one because that's the 60 degrees. I'm going to be using that one. My cosine is 1/2, but I'm in quadrant number 2, so the answer is -1/2. How was that? Was that fast, slow? Did I lose anyone?
Yeah, I got lost with that.
Okay, where?
So, to evaluate the cosine of 120, you just evaluate the reference angle of 120?
Yep, and make sure you have the right sign on it, whether it is positive or negative based on the quadrant in which you land.
But,
Yes,
When do you use the pi stuff?
we're going to do that on C and D. Look at that stuff. Look at that. It's coming up. We're not there yet. CJ first, yes.
Can you just run through it one time?
Absolutely. Okay, so let me just erase all of this. First thing I want to do is figure out where cosine of 120 is. I want to figure out where 120 is. 120 is in this quadrant. I want to know the exact value, so I'm going to see what the reference angle is. The reference angle is the rotation I need to go, or the distance I need to go from that terminal side to my closest x-axis. So I'm going to take 180, I'm going to subtract off 120, and I get 60 degrees. The reference angle for 120 is 60 degrees. We okay so far? So I can evaluate the cosine of 120 degrees as the cosine of its reference angle. However, I know cosine happens to be negative in that quadrant, so I need to make sure I put a negative on that answer. So I put a negative out front.
So when you say the cosine for 60 degrees, does that mean like what the x is?
Yeah, on the unit circle. So I come back up to the unit circle. I'm using that one. I'm using this one right here. And because I'm on the unit circle, r is 1, so my answer is just the x part of the ordered pair, and so it's 1/2. So this final answer is a -1/2. All right? How is that? Was there still questions? Yes, questions.
How do you know like which one is which? Because there's like 2 numbers there.
Up here?
Yes, like there's 2 numbers.
Okay, that's a good question. When I'm asked to evaluate ordered pairs, when I write them as ordered pairs, what do I write first as an ordered pair? What do I write second? What does this mean then? What does that have to be? What does that have to be? And since we're on the unit circle, the way we define sine is the sine of my angle is going to be my y value over my r value. But r is 1. So that's going to be the sine. So the second part of the ordered pair is my y value, and on the unit circle, that is what the sine is evaluated at. And the first one is the cosine of that angle. Does that answer your question? Anything else? Okay, cool. Go ahead and try doing those, and I'll come around and help you. So we take a look at the sine of -540. The first thing I want to do is pull off one full rotation of 360 so I can find it where I am. When I pull off one full rotation, the coterminal of that is a -180. So this equals 0. 5 pi over 4 is a reference angle of pi over 4. It's in quadrant number 3, so this is negative cosine pi over 4, which is negative square root of 2 over 2. The next one I'm going to pull off one full rotation, so I'm going to pull off here 12 pi over 6. And my coterminal angle then is going to be the sine of pi over 6, which gives me 1/2. Have a great weekend.